Hello, my name is David. So for this problem, we're given the function g of x is equal to 5 to the power of x. So looking at it right off the bat, we can tell that this is what we call an exponential function because we have the variable x in the exponent. So let's graph this by hand. So what we can do is to start by finding the intercepts. In other words, we can find the y-intercept, which is where x is equal to 0. And so by finding that, to look for that, we can plug 0 in for x. So if we were to plug 0 in for x, we have a 0 in the exponent. And as we know, anything to the power of 0 is always going to be equal to 1. No matter what the base is, if the exponent is equal to 0, the answer is always 1. Therefore, we have an intercept, a y-intercept at 0, 1. Meanwhile, we can also look for asymptotes here. Now, when we do exponential functions, there's always a horizontal asymptote here. And the graph will end up looking something like this, right? The reason for it is going to the right side when we get bigger. If we were to plug in bigger and bigger numbers into this exponent here, like let's say we plug in a 1, that would get us 5 to the power of 1, well, that would be 5. What if we plug in 2? That would be 5 to the power of 2, that's 25. Now it gets even bigger. If we plug in 3, that goes to 125, so on and so forth. And so that's why this graph here on the right side shoots up. But meanwhile, on the left side, it's getting smaller and smaller and smaller, but it'll never actually cross 0. It'll never cross the x-axis because there's a horizontal asymptote here. So why is that the case? Well, if we were to, let's say, plug in a -1, we would have 5 to the power of -1. And as we recall, when we have negatives in the exponent, that means we're taking the reciprocal of this base. So it's really 5 to the power 1 over 5 to the power of 1, which is just 1/5, right? What happens if we do 5 to the power of -2? Well, that becomes 1 over 5 to the power of 2, right? And so this becomes this, and this becomes this, 1 over 25. Right? So as you can see, this pattern continues. If we were to do 5 to the power of -3, it becomes 1 over 125. So no matter what, the further left we go, the smaller and smaller and smaller these fractions are going to get. But it's physically impossible for it to ever become 0 or to go into the negative side of the graph. So to summarize everything, this exponential function has a horizontal asymptote at y equals 0, a y-intercept at 0, 1, and meanwhile, the entire graph is increasing. And that is how you solve this problem. Thank you.